This is question number 4 of exercise 5.7 from the chapter Continuity and Differentiability. The question is find the second order derivative of log x. Now to solve this question, first of all we assume y is equal to log x. Then in this question we have to calculate d2y upon dx square. Okay, so dy by dx is equal to d by dx of log x. D by dx of log x is equal to 1 by x. And d2y upon dx square would be equal to d by dx of dy upon dx would be equal to d by dx of 1 upon x would be equal to d by dx of x to the power of minus 1. And we know that d upon dx of x to the power of n is equal to n x to the power of n minus 1. So this would be equal to minus 1 into x to the power of minus 1 or x minus of x to the power of minus 2 or minus 1 upon x square, which is the required answer. This is question number 5 of exercise 5.7 from the chapter Continuity and Differentiability. The question is find the second order derivative of the function x cube into log x. Now to solve this question we assume that y is equal to x cube log x and we have to calculate the value of d2y upon dx square. Okay, so dy by dx would be equal to d by dx of x cube into log x. So you can see it is in the form of product of two functions. So we are going to apply the product rule, and this would be equal to first function into differentiation of second function plus second function into differentiation of first function. So this would be equal to x cube into 1 by x plus log x into differentiation of x cube, that is 3x square. Okay, and this can be written as x square plus 3x square log x. Okay, now further d2y upon dx square is same as d by dx of dy upon dx, that is differentiating dy by dx again with respect to x, and this would be equal to d by dx of x square plus 3x square log x. Okay, so on differentiating further, I am going to get differentiation of x square as 2x plus d by dx of 3x square into log x. This 2x as it is, again it is in the form of product of two functions. So to differentiate 3x square log x, I am going to apply the product rule, and this would be equal to 3x square, that is first function, into differentiation of second function, that is 3x square into d by dx of log x. 3 was a constant, so it is written outside, so log x into d by dx of x square. Okay, now further this 2x as it is, differentiation of log x is 1 upon x, so I am going to get 3x square into 1 by x. Differentiation of x square is 2x. Okay, so this gives me 2x. This on simplification, this 1x is going to cancel out, so square is going to be removed, so I am going to get 3x, and this would be equal to 6x log x, and further this can be written as 5x plus 6x log x, or x into 5 plus 6 log x, which is the required answer. So d2y upon dx square is equal to x times 5 plus 6 log x. This is question number 6 of exercise 5.7 from the chapter Continuity and Differentiability. The question is find second order derivative of e to the power of x into sine of 5x. Okay, so to solve this question we assume y is equal to e to the power of x into sine of 5x, and we have to find d to y upon dx square if we assume this as equal to y. So dy by dx is equal to d by dx of e to the power of x into sine of 5x. So this would be equal to e to the power of x into d by dx of sine of 5x plus sine of 5x into d by dx of e to the power of x. So we have applied here product rule, first function into differentiation of second function into differentiation of first function. So d by dx of sine of 5x would be equal to cos of 5x into 5, and d by dx of e to the power of x is e to the power of x. And on taking e to the power of x common from both these terms, I am going to get e to the power of x into 5 times 5 cos of 5x plus sine of 5x. Okay, now d2y upon dx square, that is the second order derivative of y, would be equal to d upon dx of this value, e to the power of x into 5 times cos of 5x plus sine of 5x. Okay, so this would be equal to e to the power of x into d by dx of this term, that is first function into differentiation of second function, plus this is the second function into differentiation of first function. Okay, now this on differentiation would give me e to the power of x into minus 5 sine 5x into 5, because on differentiating cos of 5x I'm going to get minus sine of 5x into 5, because uh, here on differentiating 5x with respect to x I'm going to get 5, and differentiation of sine of 5x would be equal to cos of 5x into 5. Okay, and next this term as it is, and d by dx of e to the power of x would be equal to e to the power of x. Further, I can take e to the power of x as common from both these terms. So I'm going to get here minus 25 sine of 5x plus 5 cos of 5x plus 5 cos of 5x plus sine of 5x. Okay, and this would be equal to 5 cos of 5x plus 5 cos of 5x gives me 10 cos of 5x, and minus 25 sine of 5x plus sine of 5x gives me minus 24 sine of 5x. Okay, so d2y upon dx square is equal to, here from this bracket I have taken 2 also as common, so I am going to get d2y upon dx square is equal to 2 into e to the power of x times 6 cos of 5x minus 12 sine of 5x, which is the required answer.
Friends, thanks for watching my video. To watch more of these super videos and for the latest updates, subscribe and like the videos on these channels on YouTube, HSK Shiksha and Math Help by HSK. Thank you.